But when you look at the details of how these neurons, the system of mirror neurons, how it works, then the exciting discoveries unfold. So if I were studying your mirror neurons, what would happen is if I did an action that was just totally random, your mirror neurons would not fire. If I did an action which had kind of repetition to it even, you may not be able to figure out what I was intending to do after just one or two repetitions. But if I were to take an object that would signify to you what I was trying to do, like this bottle of water, just notice what your feeling is. So you may have noticed that the feeling was very different when I had a bottle in my hand versus when I was just moving my hand in a similar way. What that tells us is that when you know the intention behind an action, a different system in your brain is activated. We now know that that system involves the mirror neurons and other areas of the brain, so that what you do is you follow a sequence of action. And when you can predict that sequence, you can determine what the implication of that sequence is. So when I have a bottle in my hand, you know I will continue to drink like this, not toss it at you, for example. That ability to understand the sensory implications, that is what you're going to see, of the motor actions that you're perceiving, allows you to create a map in the mind, if you will, that's correlated with neural firing patterns in this mirror neurons superior temporal area complex that creates a neural representation, a neural map of my intention in your head. In other words, beyond just seeing behavior, we see the intention beneath the behavior from the very beginning. Now, that's how we create the human capacity to imitate behavior